We don't normally hear that, kid. You don't know when it starts. Thank you. So this is not really section 5.8 day one. We're actually going to do section 5.9. But here is the key for the homework. Welcome back, everybody. I didn't do the proper intro. Don't forget to hit the subscribe button, turn on your notifications.
Hit the bell.
Yeah, hit the bell.
When is the 100 subscriber special?
I know, okay, I know, I forgot the 100 subscriber special. I will do 100 subscribers.
I made you a YouTube intro during that one class where you had to catch up. Maybe I should probably send that to you. Pretty
You
good.
made me a YouTube intro?
Yeah.
Would you send it to me?
Yeah.
It was like 15 seconds long.
I know. I got it because it got like, I don't know what happened, but it got way longer. So there's a bunch of blank time before. But it's okay.
I can edit it.
Okay. Thank you.
Send it my way. I'm interested to see it.
If it's like your face on the kitchen lamp, it's
I
like
know.
Romy or something. I like just picture that as something. Yeah, like you only like see cool faces on like characters.
Yeah, like a Jim Jeff thing.
Characters. I was gonna say cartoon.
Okay, what questions do we have? What do we want to go through? Those are all the answers, but obviously it doesn't work. Yeah. Yeah. So we got x squared minus 9x is greater than negative 18. Okay, so I add the 18 over to the other side. X squared minus 9x plus 18 is equal to 0. Again, treat it like an equality. Should be doing this on the smartboard so the folks can see that. Oh. And then we factor. Can I factor that? Does that factor?
Yeah.
6 and 3, right?
Yeah.
So it turns into x minus 3, x minus 6 equals 0. So that means I've got x equals 3, x equals 6. I go to my number line, 3, 6, open circles on those. Let's pick a test point of 0. Let's go 5 and 7. So we run those numbers through. If I plug in 0, that's going to give me 0 is greater than negative 18, which is a true statement. So this is a yes. If I plug in 5, that's going to give me 5 squared minus 9 times 5 is greater than negative 18. So negative 20 is greater than negative 18, which is a no. That's a false statement. And then when I plug in 7, 7 squared minus 9 times 7, that's going to give me negative 14, which is greater than negative 18. That's a yes. So therefore it goes over here, x is less than 3, or x is greater than 6. Ah, that would be an issue. Questions? Yes?
You do number 5.
Sure. I'll do this one on the Number 5, you said, right? Okay, we got x squared plus, minus x minus 3 is greater than x. Okay, first things first, got to set it equal to 0, right? So subtract the x, and let's turn it into a equals 0. Right? Factors of negative 3 that add to get to negative 2. Are there any? Let's see, is it factorable? Yep, it is. Oh, duh. Negative 3. X minus 3, x plus 1 equals 0, so x equals 3, x equals negative 1. We're good so far? Number line, negative 1, 3. So let's go negative 2. I don't know why I'm putting them on the top and bottom there. 0. That's going to annoy me. Negative 2, 0, and let's go 5. I don't know. So if I plug in negative 2, that's going to give me 4 plus 2, so 6 minus 3 is 3 greater than negative 2. That's a yes. If I plug in 0, that's going to give me negative 3 is greater than 0, which is a no. If I plug in 5, that's going to be 25 minus 5 is 20, minus 3 is 17. It's greater than 5, which is yes. So that means we've got solutions out here, out there. So that's an x is less than -1 or x is greater than 3. Good there? What other questions do we have? Anything else on the homework that we'd like to talk through? Yes,
No.
9. The word problem.
I was gonna say, there's just like words that I.
Sure, right here. I'll just put it on the board. Here's number 9. An online music service that sells song downloads models. This is so funny. Like back in 2008, this was so hip. An online music service that sells song downloads. I wonder what they're saying. But back then it was like, oh, you could buy music on like a lot of different platforms. Like now it's just like, oh, you just go on iTunes. Do they even like buy music anymore? You just stream it, right?
I mean, you can.
I know you can, right?
feel like membership.
But I mean, like, do you guys buy music anymore?
I just pirate it.
You just pirate it?
Oh, wait, that's on the video now.
Yeah, I know. That's Caleb Yost, Y-O-S-T.
That's not how you spell it. There's an accent.
Accent on the
Wait,
T.
is this the same Caleb that wanted to shout out?
Yeah. I think
In what
so.
video?
I don't know. He always lets me know.
Well, you just got it.
I know.
Yeah,
Negative shout out.
FBI.
Right, here's my equation. That's a weird 0. An online music service sells song download models its profit using the function P of D is equal to -5D squared plus 450D minus 1,000, where D is the number of downloads sold and P is the profit. How many downloads does it need to sell to make a profit of more than $8,000? So honestly, this is what I'm looking for, right? I want to keep profits above $8,000. Okay, so treat it like an equality and subtract over the 8,000. I'm going to get -5D squared plus 450D minus 9,000 is equal to 0 because I subtract over the 8,000. Now at this point, I got to be honest, those all look like I can divide by 5, don't they? You know what? I bet you probably didn't catch that. But if I really wanted to make the numbers smaller, if I was worried about the numbers getting really big within the quadratic formula, you could divide everything through by 5 here if you really wanted to. And to make it even better, you could divide by -5. But if you didn't catch that, A would have been -5, B is 450, and C is -9,000. Okay, so the opposite of B plus or minus the square root of B squared minus 4AC
I've never heard that running before.
all over 2A. Does that make sense? Let's plug it in. 450 squared minus 4 times -5 times -9,000. And then I square root that, because again, I don't care if it's going to come out a perfect, oh, it is a perfect square. But I really didn't care because at this point, this is a word problem. I need to figure out where it's on my number line. I need to know the exact value. Yoda, where do you go first period? Are you just free first period? Where? I go where I want. Okay, cool. You can just sit on my desk, mate. All divided by -10. You can stay if you want. We're learning about powers of I today.
Oh, that's so exciting.
You remember like I squared, I to the third, I to the fourth?
I don't want to.
Okay, got it.
I thought you said today was fun.
It is.
Sorry, guys.
It is fun. What's that? That's a 150, yeah, sorry.
What?
150.
It's like, hey, that looks like,
You're dysfunctional this morning.
you're welcome.
It's before 8 a.m. Blood.
That's right. That's a rule.
thought it was
But he still makes
8:15.
mistakes in my
I
class.
just say whatever time is like right next to it.
Holy world.
So let's say I don't make mistakes.
I
Ever.
think you should say before noon. I think
That's before noon, yeah.
My class is still after that.
before the end of the school day.
It's still before 2:30. So 30, -450 minus 150 divided by -10. 60. So those are my two critical points. So let's pick what? Oh, really? Let's pick some testing values here.
Could you have reduced down negative
You're-
450 and negative 70?
Say that one more time.
Could you have reduced down negative 450 and negative 70?
Yes, but I didn't need to because I wanted to get these values anyway, and it came out to be a perfect square. So I want to do the plus and the minus first before I divide by negative 10. Okay, so let's pick 0, 50, and 70. Okay. If I plug in 0, I'm going to get negative 1,000 is greater than 8,000, which is not the case. If I plug in 50, that's going to give me negative 5 times 50 squared plus 450 times times 50 minus 1,000. So 9,000 is greater than 8,000, which is a yes. And then I plug in 70. $6,000, which is a no. So I say here to here. Is it or equal to? I just said greater than, right? Yeah, because it says within the word problem more than 8,000. So we say for x is less than 30, or x is greater than. Oh wait, no. I'm sorry, I did that wrong. Did I do it the other day too? What? Yeah. So it's just in here that my solutions are. So in between 30 and 60. Downloads? Is that what D is? Downloads? And if I wanted the inequality, I would write it like this. All right. Any questions on the homework? Anything else they want to talk through? Okay. Let's get back to section 5.9. So again, in this set of lessons, section 5.7 and 5.9, ones that I would say don't really fit anywhere else, right? Kind of like a hodgepodge of lessons in here. We have this section on operations with complex numbers. You guys remember what complex numbers are? Remember, complex numbers are the ones that are formed by A plus BI, by a real part and an imaginary part.
You have a completely different order for this class.
You are throwing me off today. You are really throwing the balance.
No, but you go
Like,
a different
I
way
feel
when
like-
you're delivering the papers in each class. I'm just observing. I'm like that teacher that sits in the back of the class and takes notes. Well, I'm not actually.
Yeah, I don't hear anything. All right, so we know that complex numbers are of the form A plus BI. Okay, so what we're going to do today are take those complex numbers in the form A plus BI. We're going to add, we're going to subtract, we're going to multiply, we're going to divide them. We're just going to look at how do we operate with these complex numbers. Adding and subtracting complex numbers is really quite easy. Okay, it's really quite easy. All we're going to do is just kind of like combine like terms, because obviously there's a real part and an imaginary part, right? There's a real part and an imaginary part to complex numbers. So therefore, all I'm going to do is just add or subtract the real parts and then add or subtract the imaginary parts. We do have all the properties of real numbers. Complex numbers do include the commutative, associative, distributive properties. We could do all of that. So we aren't restricted in that respect, and we can use all of those properties. Let's take a look here. And this says no graphing calculators. We really don't even need calculators. Just no. There's no calculators. You should not need your calculators for this. Usually if we do an assessment over this, obviously our assessment on this is gonna be our exam, because we're not gonna have time to do another assessment before the exam. But usually if we have time to do an assessment, the 5.7 and 5.9 stuff, or at least this stuff, the 5.9 stuff is no calculator. But you guys like that. Okay, let's take a look here. I'm just adding. So let's combine real parts, combine imaginaries. Yeah, it's literally just that simple. Okay. All you do is combine real and then combine imaginary. So 4 plus a -6 is a -2. 2 plus a -7 is a -5. Okay, that's not bad. That's easy, right? So if I want to do subtraction, 5 minus 2i minus -2 minus 3i, I think the best route to take, since there's a minus sign, and again, we see complex minus another complex, right? That's what we're looking at here. Got it. The best route to take would be to distribute in the negative. 5 minus 2i plus 2 plus 3i. Just distribute in the negative. That's the best route to take. And now we just combine like terms. 7 plus I. Pretty simple, right? Adding and subtracting, very simple. So we have 2i minus 3 plus 5i. Yes, 2i is still a complex number. It's a complex number with only an imaginary part. You could say like 0 plus 2i, if I really wanted to. But we just distribute in the negative. 2i minus 3 minus 5i. Don't forget, always put the real part first. A plus bi. -3 minus 3i. And let's do one more of those. We've got 4 plus 3i plus 4 minus 3i. I add together these, I get 8. 3i plus a -3i. What do I get? 0. Those two things have a special name. What are they? You guys remember what those are called?
Additive inverses.
No, they're not additive inverses.
That was close.
What's different about these two? The plus and then the minus. What do you call complex numbers where I change the sign of the inside? The conjugate. Yes, they are conjugates. They're called complex conjugates. So what are we noticing here? That if you add complex conjugates together, what happens to the imaginary part? It disappears, it goes away. Okay? If you add two complex conjugates together, the imaginary part will go away. All right, now we get to do something really fun. The imaginary unit I can be raised to higher powers, as we can see here. Or it's not shown below yet, I will show it. But why do we need this? Because eventually we're going to be multiplying with complex numbers, which we would need to take, I squared. Or maybe even I to the third. Or maybe even I to the fourth. So what is that? Well, let's take a look here. I to the first power, actually, I'm going to even start. Okay, scribble that out on the left side. I'm using Mrs. Napolz's guided notes, and she starts with 1. I always start with I to the 0. Ooh, I don't want to do purple. Let's do blue. No, you're only going to want a cycle of 4. What is anything raised to the 0 power, folks? Could be Mr. Laverick raised to the 0 power. Just 1, right? Anything raised to the 0 power, even including I, is 1. Okay, what is anything raised to the first power? itself, right? So like 2 to the first is 2, 3 to the first is 3. So I to the first is I. Okay, let's analyze I squared. You think? Because what is I?
Imaginary.
Yeah, but what is it? I is what? What do we define I to be? Square root of negative 1, right? So this is really like saying the square root of negative 1 squared. So what would that be? Negative 1. Because the square takes off the square root symbol. So I squared is actually negative 1. You'll use that a lot. I squared being negative 1. Okay, what's I to the third power then? Well, we can define I to the third to be I times I squared, right? I to the first times I to the second, because all I would do is add the exponent to make it an I to the third, right? Well, what was I squared? Negative 1. So this is really like saying I times negative 1, or negative I. So look at what we have here. I to the 0 is 1. I to the first is I to the second is negative 1. I to the third is negative I. 1, I, negative 1, negative I. Okay, so let me ask you this. What is I to the fourth power? What would I to the fourth power be? Well, let's kind of analyze it. I to the fourth would be I squared times I squared, right? Would that be I to the fourth? I add the exponents above. 2 plus 2 is 4. What's I squared? Negative 1. What's negative 1 times negative 1? Positive 1. Let's check I to the fifth. Let's check I to the fifth. Well, wouldn't I to the fifth be I times I to the fourth? Like I to the first times I to the fourth? Because I would add exponents, it would be I to the fifth. Well, that's like saying I times, what's I to the fourth power? What did we just find it to be? So I to the fifth is just I.
He's still counterintuitive. It'll just be I.
Just wait.
Okay.
What about I to the sixth? Well, isn't this just I to the first times I to the fifth? So this would be like saying I times I, which is I squared, which is what?
Oh my gosh.
What do you think I to the seventh is going to come out to be?
3.
Negative I. Negative I. Negative I.
Let's check it.
It's just a giant pattern. Well, not giant.
So this, not giant.
It's just one
So
eye.
this would be like saying I times negative 1, so negative I.
But why have the first 4?
So take a look at what we have I to the fourth, fifth, sixth, seventh. 1, I, negative 1, negative I. Just like we had with I to the 0 through I to the third. Or I to the, yeah, I to the third.
Yeah, well, this is all your fault.
What do you think,
Yeah, my bad.
what do you think I to the eighth is going to be? What do you think about I to the ninth?
2.
What do you think about I to the 10th?
Negative one.
What do you think about I to the 11th?
Negative I.
So what we have here is a cyclic pattern. Okay, this happens several times in math. Cyclic, like it happens in a cycle. Yeah. Sorry.
I'm sorry.
Cyclic. Right? It happens in it. You know the word cycle, like bicycle, like cycle, right? Cyclic.
What?
Alright,
What? That does not work. Okay.
I get
I
it.
thought
That is a word, Caleb. Thank you.
Well, I know it's
I know my mathematical terms. This is called a cyclic pattern. It happens in a cycle.
I'm
Out
just
of
saying
four.
it just doesn't. Okay, well, you're insulting your teaching.
So what we have here is a cycle of 4. Now, this is very interesting because any power of I can be reduced down into one of 4 things. Like, for example, if you've got I to the, I don't know, 53rd, I know it's got to be one of four things. All that will come out to be one. What do you notice about their powers? 4, 8, 12, 16, 20. They go up by fours. They are a power of, or they are a multiple of 4. Okay, so what's the closest multiple of 4 going up to 52? Well, I would get up to 40. 40 is a multiple of 4. 44, 48, 52. So I to the 52nd is right here. So I to the 53rd is just I. Now, some of you, have you guys talked in maybe computer science classes about modular arithmetic?
Sadly.
Yeah. This is mod 4. This is math mod 4. Now, those of you who don't know what this is, modular arithmetic is like clock arithmetic. Like if I asked you, like military time, 1600 hours, what time is that?
4 o'clock.
4 o'clock. How did you get 4? Subtracted by 12. I took out a cycle of 12, right? I took out 12, because that was kind of like my base. And that's the remainder, right? The remainder is 4. So I take out cycles of 4, and whatever the remainder is my power. So let me show you again with 53. 53, I have, what was that? I had 40, that would have been 10, 11 is 44, 12 is 48, 13 cycles of 4. 53 is 4 times 13 plus 1. 4 times 13 plus 1. That plus 1, my remainder of 1, becomes my power. Okay? So this is really going to act like I to the first, or just I. Let me show you with another example. Give me a power of I. I to the, what was that? 80 what? 87. I to the 87th power. So here's what I'm going to do. In my head, I don't want to go through all of those cycles. I guess I could go up to 80. 80 is an easy one. But 87 divided by 4. Okay, I have 21.75. Isn't that 3/4? 21 and 3/4. 21 and 3 remainder. So this acts like I to the third. So this is negative I. Okay. What did I do there? Again, I divided by 4. I wanted to figure out how many full cycles of 4 I had within 87. How many full cycles of 4 did I have within 87? I had 21 full cycles of 4. And then I had a remainder left over of 0.75. 0.75 is 3/4, right? So I had 21 and 3/4. The remainder left over, like if I took 21 times 4, I get up to 84. So I know 84th would be on my top row. Then I go 85th, 86th, 87th. But I had 3 remainder, right? I could have found that from the 0.75. I didn't need to go through that process. 0.75 is 3/4. That 3 becomes the power. I to the 87th is I to the third. Those things are the same. Mod 4. Yeah.
Is there anything that I to the second or I to the third? Because you have the second.
Well, I to the 8th is like I to the 0. So you have to start your pattern at 0.
If it's 3 after the 4 sequences, then it'll be.
So we have to go 1, 2, 3 right here.
But it starts at 1.
Starts at 0.
Yeah.
Yeah.
Like that's 1.
But I had the remainder is the power though. That's the problem. The remainder is the power. So if it's a remainder 3, then the I to the third becomes the power.
So is the remainder to the next whole number?
Say that again?
Is the remainder to the next whole number is the exponent then?
Yeah.
Okay.
Yeah. So give me another one. Let's do one more just for fun.
143.
143.
3,945.
You know what, let's go bigger. What was that, 3,000 what?
944.
3,944. Okay, it doesn't matter. I could do numbers really big. I don't care. 3,944 divided by 4, because all I need to do is figure out what this is, mod 4. This divided evenly. Is there any remainder?
No.
What's my remainder then?
0.
So this acts like I to the 0, which is just 1. I know, see? This is cool. Let's do another one. This is so much fun. I to the what?
3 billion.
2 million what?
347,892.
And 6.
So I take 2,347,892. I divide it by 4.
Can you do negative?
Holy chicken nuggets, that came out even 2. So this is actually I to the 0 again, which is just 1, because there was no decimal, right? It's always either going to be 0.0, 0.25, 0.5, 0.75. It's always going to be remainder of 1, 2, 3, or 0.
Can you do negative numbers?
Let's not think about that right now, because then, now think about what a negative exponent would be. A negative exponent would actually be a fraction, would be down in the denominator, which if there, hold on. Because if there's a negative exponent, it will go down into the denominator, and technically I is a radical. I would need to rationalize that as well, which we talk about a little bit later, probably in pre-calc and calc. All right, so let's jump back to this. Moral of the story is we just want to graph, or just want to multiply. Just want to multiply.
That was fun.
That was fun. Wasn't it?
I was.
So let's multiply in. I've got negative 4i plus 8i squared. That's an I. Right? I mean, that's pretty simple, right? What is I squared? Negative 1. So this is like saying negative 4i minus 8, because it would be 8 times negative 1, which is negative 8. Really, an I squared just turns real, right? It takes the imaginary part, turns it real, and makes it negative. And now we write it in true a plus bi form, negative 8 minus 4i. What do I imply to do here? I'm sorry, did you want to go back up? Yeah. What am I implying that I have to, that I have to do with this next example? Foil. I have to foil this. So let's do that. First, outer, inner, last. Okay, so this is going to give me a 12 plus 21i plus 6. Right, the I squared is a negative 1, which turns that negative 6 to positive 6. It'd be negative 6 times negative 1, which is a positive 6. And now at this point, I say 18 plus 21i. So whenever you FOIL two complex numbers, your last should end up being real. Your last should end up being real. Should. As long as they were both originally in that A plus BI form. My Algebra 2 teacher said it might be a better idea to FLIO then, instead of FOIL. Because first and last are going to come out real. Right? First and last are going to come out real. Inners and outers are going to come out complex. So do first, last, they kind of group together with the real parts and imaginary parts. Let's do this one here. Do I have to do any sort of distributive properties? No, this is just multiplication. Kind of put a little bit easier example in here, just so that you guys remembered that It's just negative 30i squared. So what's that turn into? 30, which is an interesting statement. All I did was multiply two imaginary units together. This is an interesting thing here. If I multiply two imaginary pieces, what does it come out to be? Real. It comes out to be real. An imaginary times an imaginary is actually a real. What do you see about 2 plus 9i and 2 minus 9i? What are those called again? Conjugates. So we added them together and it came out real. Let's take a look at what happens when we multiply conjugates together. First, I'll do FOIL. Out, in, last. What happens in the middle? Because this is truly a difference of squares, isn't it?
Yeah, 2 times 3.
It's 18.
No longer. I wasn't whispering about it already.
Man, it's 8:20. It's late. It's late for a mistake, folks. I'm sorry about that.
It's not 8:30.
So it's 7.
It's not 8:30. I can make a mistake before 8. I can make a mistake before 8:22. Oh. So I've got 4. Then this turns into plus 81 I squared. 81. Yikes. Whoa.
I'm so glad I could bring it.
I knew you were thinking.
Oh, wow.
Caleb,
This is all, I'm saying this is all Caleb's fault.
But this happens in my period. Oh wait, okay, I'm in there.
Yeah, I know. That's what I'm saying. I never, right? I never make this, right? I never make mistakes. I'm perfect.
It's actually recorded every time.
Yeah, really.
See, but isn't this better than your normal class? Isn't it more exciting?
Caleb, I've already tuned you out. I can't hear what you're saying anymore.
He seems a little more flustered.
Yeah.
What happened with the art?
It turned into -1, which made 81 positive. I really feel it too. I feel a little bit more stressed because he's in here.
You don't need to feel intimidated. I'm just giving you a bad
Yeah,
review
trust me,
on
I'm not intimidated. That is intimidated.
by the 95.
I am not intimidated by Caleb Yost.
But the record
to
shows.
bleep out the part where Caleb Yost said that he fired thing.
Yeah, no, I don't need you to bleep that out. You can just leave that out.
Exactly.
Okay, so let's take a look at some powers of I real quick. This would be like saying -6 times I to the 14th. What does I to the 14th act like? I to the what? I squared. Right? Think about it. 14, remove 3 cycles of 4. I get up to 12, I've got 2 more, 2 remainder. So this acts like -6 times I squared, which is -6 times -1, which is +6. Right? How did I get there? I could have taken 14 divided by 4 in my calculator. Okay, so it's 0.5. 2 fourths. 2 remainder. I squared is my power. Try that again. 1/2 I to the 7. Well, that'd be like saying 1/2 times I to the what? 3rd. I mean, I only take out 1 cycle of 4, 3 left over. So remember, it's 1 I, -1, -I. So -1/2 I. What would I to the 42nd be? Remainder 2, right? So it's going to act like I to the 2nd, which is -1. Remember, I've got, it's really close to 40, right? 2 remainder after I divide out factors of 4. 44, doesn't that divide evenly? So that's going to act like I to the 0. There's a 0 remainder, which is just 1. Okay, The last thing that we're going to talk about here are dividing these complex numbers. I've got 3 minutes to talk about this, and that's totally fine. Technically, and we had this discussion already, technically I is a radical, right? So this is not simplified as it is. What I have to do is rationalize the denominator, right? Because technically I is in the denominator. I can't leave an I in the denominator because it's technically a square root. Okay? So I want to get that out of the denominator. Guess what I would multiply by to make it real? To take the I and remove it. What would I multiply by? Its conjugate. I would multiply by the denominator's conjugate. Okay. I would multiply by the denominator. I would take the conjugate of the denominator. Because if I multiply by the conjugate, we saw from up above, if I multiply by the complex by its conjugate, it's going to be like a difference of squares. It's going to cancel out. It's going to be turn into real. Like the bottom is going to become first, outer, inner, last. The denominator is just going to turn out to be 1 plus 1 or 2. Now I've got to FOIL the numerator, obviously. But I'm just showing you that's why you would multiply by the conjugate. So FOIL the top first, outer, inner, last. So the middle becomes 4 plus 2i, and then the last becomes plus 2. Change the sign because it's an I squared. 6 plus 2i over 2. Question?
Why is it not
What is
5
it?
minus 1? Like, why is it 1 plus 1?
Because this is a negative 1.
Oh, it's already negative. Okay, I see.
See that?
Yeah.
I can reduce that. Be careful, I can reduce that. 3 plus I. Divide left and right side by 2. Well, that was fun. That was a fun day.
You're welcome.
Oh, geez. You're throwing me off, man. You are throwing me off. That's my